Halo, halo, słychać mnie?
Tak, ja Cię, Paweł, słyszałem. A mnie jak słychać? Nie wiem, jakiś
Dobrze
problem
się
z
słychać.
ustawieniem. Dobra, teraz już będzie git.
Hello.
Hello, Simon.
Excellent.
Hi, Simon.
Hi there. Let me know when you want me to share my screen.
I think we can start.
Okay.
So, I'm talking to Arthur. So, Arthur, let's start. It's like
Okay, so if
the
we
time.
could start. So hello, everybody on 30. Give me a second. I have second screen sharing on Zoom. Simon, I will share screen for a moment.
Okay, yeah, sorry. My bad.
No problem. So again, hello, everybody. And I'm really glad that you are all came here. Of course, sponsors of our today's meetings are Virtus Lab, the main events and founding sponsor of KJUG Java user group, JetBrains, developers of the best Java IDE, of course, in the world. And we have today some licenses for you sponsored by JetBrains. And last but not least, as always, Manning Publications is a sponsor of Books for You. Of course, you can find information about KJUG Java user group on various platforms like Medium, Twitter, Meetup, etc. Okay, maybe now some organizational things. If you have question, please ask it only via Zoom Q&A section, not on by YouTube channel. Second point, if someone would like to get voice, just raise your hand on Zoom. Then we will active this feature for you. And last thing, everyone who watched this stream, as I said before, can win some rewards, JetBrains licenses and books from Manning Publications. To have a chance, you need to watch the presentation carefully and be ready for questions that Simon will ask. And the fastest correct answer on chat will win. And additional information, please choose option, send message to all panelists and attendees, not only to panelists. This option is above chat. And now what is most important. Today, our guest is Simon Ritter. Simon will tell us today about local variable type inference. Simon currently is Deputy CTO of Azure Systems. Simon is associated with Java from very beginning of Java from 1996 from version 1.0. More details about Simon experience you can read in his bio. His achievements are really impressive. And Simon, we are really happy and excited that you are agreed to our invitation and that you are here with us today. And I think that it will be all from my side. So, Simon, stage is yours.
Great. Let me slides. Okay. Start. Okay, so hopefully you can see my slides.
Yes, we see.
Good, good. Excellent. Right. So, yes, we are going to talk about local variable type inference. Is it a friend or is it a foe? So, yep, there we go. So the first thing we need to talk about is a little bit about the basics of how Java stores things. And obviously, Java is an object-oriented language, so we have the concept of classes. Classes encapsulate things. And part of that is state, which we do through fields that we create. So we have instance variables for our objects. And the thing about those is that they are part of the object. So they exist for the lifetime of the object. And the important thing about those is that the initialization is guaranteed by the compiler. So we know that if we create a Boolean as a field in our object or our class, then it's going to be a false by default. Similarly, if we create a number, it's going to be 0 by default. Now, the other type of storage that we use a lot is local variables. So this is where, rather than being part of the class itself and part of the object when we instantiate it, these are local variables which are scoped to certain areas of our code, certain regions of our code. And that scope can extend depending on how we want it to work. So we could have the scope of a method. We could have a scope of a statement because we could put it inside braces, or we could have the scope of a block. Again, if we want to separate out things, we can put them within braces, and that will enable us to specify how long we want that variable to be accessible. Now, the important thing about these is the initialization is not guaranteed. Because they tend to be allocated on the stack, whatever's on the stack when we allocate that space for that object is what it's going to be initialized to. So we don't know that, for example, if we have a Boolean, that it's always going to be false. It could be false, it could be true, depending on what's on the stack. And when we use these, the name that we use for them is often more important than what the type is, because we don't always need to kind of worry too much about the type. We look more at the naming of the variable. So that's what we need in terms of Java storage basics. So the first question we have to ask is, why add local variable type inference to Java? Local variable type inference was introduced in JDK 10. And so that was something like 24 years after Java was first released. So you got to think to yourself, why did we need to add it at this point? We've survived without it for a long time. Why is it we actually need it now? And you can come up with a number of answers to this. The first one I came up with was, well, JavaScript's got it, so it must be good. That's probably not a particularly good justification for why we added it. There are better ones. And if we look at things like streams, so streams introduced in JDK 8, very powerful, allows us to have more of a functional style programming added to Java. But if we look at an example like this, what we're doing here is we're hiding the intermediate types, because all we're really interested in this particular set of statements is what is the type that's being returned from that set of instructions. So we take our names, which is obviously a list of some description, and we create a stream from that. And that creates a stream of strings. We pass that to filter, which is going to remove certain elements from that stream. So we keep a stream of strings. Then we're doing a mapping to get the records from that. So now we convert it into a stream of records. And finally, we collect it into a list, which is a specific type of list, an array list type record. But in terms of what we're dealing with there, we don't worry about what those intermediate types are. We don't need to think about them. All we're really concerned about is, okay, we're going to get a list at the end of it. What are we going to do with it? So why not expand this kind of idea to other places in the Java language? And what we do is we use var as a new way of saying, okay, let's, rather than specifying the type of a local variable, let's use var, and let's let the compiler figure out for us what that type is. And the important thing about this is to enable us to still have very readable code. We're going to come back to this kind of concept a few times when I talk about some of these edge cases and things about how you use local variable type inference in the most effective way. So what we don't want to do is sacrifice readability. Right, let's look at some simple uses of local variables as we would have done before using type inference. Here's a very obvious example. I want to create an array list, and we're using generics. So we'll give it a generic type parameter, and we'll say it's an array list of type string. We're going to call it namelist. And then in order to assign something to it, we will instantiate an array list of type string. If you look at that code, it's very verbose because we're replicating the fact that it's an array list of type string on both sides of the assignment. Why do we need to do that? Really doesn't make any sense, does it? Because obviously, if we are creating a new array list of type string, when we assign it to a variable, surely the compiler can figure out that the type of that variable is going to be an array list of type string. If you go back to JDK 7, we actually started doing a little bit of tidying up on this by the introduction of the diamond operator. And what this allowed us to do was say, okay, well, we know that the generic type parameter on the left-hand side of the assignment is string, so we can leave out the generic type parameter on the right-hand side, and the compiler can infer that for us. So we'll just say array list, diamond operator, and then instantiate that. And then the compiler figures out for us that the generic type parameter is string, because on the left-hand side, we're saying it's a list of type string. So at least that's a start, but it's not going quite far enough. We can use other instances of local variables. So if we take our user list and we extract a stream from that, then obviously the variable that we're going to assign it to is going to be a stream of type string. And in this case, it's not quite so obvious because we have the fact that we've got a user list there rather than the type that we're instantiating. We're retrieving it from the user list. And then we have other instances where we might use a for loop, and we use the more modern for each syntax. So we do for string name over user list, and it will iterate over user list and return the elements of it. And of course, the good old for loop, one we're all used to, for int I equals 10, I less than 10, I plus plus. Now, if we use local variable type inference, we can replace all of those statements in a slightly different way. So the first thing we can do here is we can say var user list equals new array list of type string. The compiler at this point can infer for us that user list is going to be an array list of type string. So we don't need to specify a second time on the left-hand side of the assignment. We just let the compiler figure that out for us. Similarly, if we want to retrieve the stream from that user list, the compiler can figure out easily enough that since user list is an array list of type string, then the stream that we get from that is going to be a stream of type string. We can replace the explicit type in our for loop, and so we could say for var name over user list. User list is an array list of type string, so the compiler can easily infer for us that name is going to be a string. And then lastly, if we wanted to, we could replace the int in our traditional for loop with var and say for var I equals 0, I less than 10, I plus plus. This is one of those examples where I would say to you, do not do this. And the reason I say that is because var has 3 letters. Int has 3 letters. There is nothing to be saved by replacing int with var in this particular example. So I would never do this because all you're doing is making it slightly more harder to understand what's actually going on in that code. If you put int explicitly, it's obvious that that's an int. If you put var, you might think, oh, does it actually infer an int or does it infer something else? So don't use var in that particular instance. Another good use of var is sort of tidying up your code and making it easier to read. And here's a good example. So try with resources. And in this, I've been deliberate in terms of making it quite verbose and using variable names which are repetitions of the types as well. But we end up with some very dense code. And if you look at that and just try and figure out what's going on, you've got to look quite carefully to understand that we're actually creating 3 different variables there. We've got an input stream, then we've got an input stream reader, and then we've got a buffered reader, because there's lots of repetition of all of those things. We've got input stream reader equals new input stream reader, and then buffered reader equals new buffered reader, and so on. Very, very dense and not easy to look at and see exactly what's going on straight away. If we use var in this particular instance, we can tidy things up. So now we can kind of align things more nicely. We can avoid some of the line wrapping that we had, and we can say, okay, var input stream reader, var buffered reader. And you can look at that and see, okay, we're getting our buffered reader from the two types that we've got, two variables we've got above that, and it's all just a little bit easier to read. So this is a good example of where we want to use var. Okay, so let's dig into some of the details of var and look at how it works in a bit more detail and some of the things you need to be aware of when you want to use it. So the first of these things is that unlike in JavaScript, this means that Java is still very much statically typed. If I do something like this, where I say var name equals Simon, the compiler is going to infer very logically that name is a string. Good. That means that I can then reassign a string to that variable. No problem at all. I can say name equals Dylan, and that will work perfectly all right. If, however, I try to do this and I say name equals 42, because although I've used var above, the type has been set at the point where I've created that variable. So name is set to be a string, and there's no way that we can change that type and make it dynamic. So if I try and assign 42 to name, it's not a string. It's not even we can't convert it to an int, or an integer isn't a type of string. So it's just not going to work. And the compiler will correctly say incompatible types, int cannot be converted to string. Next thing is about final and non-final variables. And the thing to understand here is that var simply indicates to the compiler that you want it to figure out what the type is for you. So you want it to infer it. It doesn't tell it anything about whether it's final or non-final. Well, actually, it just says it's non-final. So var, as we've already seen, we can say var name equals Simon, and then we can change that, say name equals Dylan. So name is, in this case, not final. If we want name to be final, then we still have to use the modifier, and we have to say final var name equals Simon, and then we can't change it. Well, unless we use reflection, but that's another thing. Now, this was something that caused quite a lot of discussion on the mailing lists when local variable type inference was being developed. And people said, well, other languages have a way of having var, but you can also specify at the same time that the thing that you're creating is final as well. So you can things like val or let. So there's different syntactical approaches to this. In this particular case, the decision was made that they wouldn't do that. So you do still have to explicitly state that a variable is going to be final using the modifier as you would before. And I have to say that if I think about when I'm using local variables, I don't often make them final. I know I've had this discussion with lots of developers, and some people have said, well, yes, I still, make a lot of local variables final, but I don't tend to do that. So I make final variables in the instance variables, but not so much for local variables. So it's kind of something that's, again, discussable, but they decided not to do that. Next thing, action at a distance. And this is one of the things you do need to consider when you're going to use var, and think about when somebody comes to read your code, how easy is it going to be to understand what's going on? If we look at this piece of code here, I'm using var and I'm saying, okay, I'm going to create a new array list of type string, and I'll assign it to a variable called L. Okay, L is not a particularly descriptive name, and then we'll have S as L.stream. But at that point, it's pretty easy to see what's going on because it's the next line down. So we can see, okay, well, L is an array list of type string, so var S is going to be a stream of strings. If, however, we have lots of code between those two lines and this line here where we say var n equals L.get 0, then suddenly it's going to be, ooh, hang on, well, what is L? And so because you're not explicitly putting the type of n in the code, you would then have to sort of scroll all the way back up and find, well, where did I define L? Oh, okay, L is a new array list of type string, therefore var n is going to be a string. So this is one of the important things, is to think about how easy is it for somebody to understand your code if you use var. And so what you don't really want to do is just go through and refactor your code and say, okay, wherever I've used explicit types, I'll just replace that with var, make my code a little bit shorter and tidier, because you might lose some of the readability of your code. Obviously, in this example, you could solve part of that problem by making your variable names much more sort of explicit and saying, okay, L is list of names or something. And so it would be obvious then if you got n equals list of names dot get 0, probably going to be a string. Now, some of the other things to understand about local variable type inference is that not everything can be inferred. Let's look at this example. In this case, what I'm saying is I've got an array of ints, which I'm going to call first 6 primes, and I'm going to assign values to that, which is 2, 3, 5, 7, 11, 13. Good. And you might think to yourself, well, okay, let's use var for that. Now, in this case, okay, we could save 2 characters, potentially, and say var first 6 primes equals 2, 3, 5, 7, 11, 13. However, that's not going to work, and the compiler will create an error. It will say, cannot infer type of local variable first 6 primes. Array initializer needs an explicit target type. Why is this? Well, the answer is that in Java, you have 2 types of expressions. You can divide expressions into 2 types. First type is a standalone expression. And a standalone expression is one where the type can be determined by the expression without knowing its context. So if you say int I equals 3, then obviously you know that the variable I is going to be an int and it's going to have a value of 3. But there are certain expressions which are called poly expressions. And poly expressions are where the expression has different types in different contexts. And this is one of those examples. The reason for this is that if you take away the fact that it's an array of ints, depending on where you used that array, the type could be different. If I show you how we solve that problem, it becomes a little bit easier to understand. So the first thing is you could say, okay, var first 6 primes, and then we have to explicitly state on the right-hand side, new int array, and then the values that we want to put into that. So at that point, it becomes completely explicit what the type of that is. So var can be inferred quite happily. The reason we can't do it above is because we could also do something like this. We could say var first 2 primes equals new, and then use the integer wrapper type as an object, array 2 and 3. With auto boxing, that's going to create integer objects. And so you can see that in the case of those 2 vars, they have different types. And depending on where you would use them and where they're actually defined here, then it's not clear if from above what the type of first 6 primes would be, because it could be an int array, or it could be an integer array, or it could be an object array. So it's not clear, and the compiler will therefore reject it. Types are required on both sides. Again, okay, so let's look at this example. Here we've got var list equals null. And you might think, okay, that should work, shouldn't it? Well, no, it won't. And what you'll get here is variable initializer is null. A lot of people would look at that, and I know I certainly looked at that when I first took this example, and think to yourself, well, hang on, well, if the compiler is trying to infer the type, a null, okay, well, we know that in Java we have a type hierarchy, and we know that the top of that type hierarchy, everything inherits from object. So surely we could just say list is an object. Object list equals null, and that would work. Well, yes, it would. But the tricky bit here is understanding that in terms of the Java type hierarchy, object is at the top. And then all your classes will inherit from object. And clearly you can have you can have inheritance which goes down through a chain of different classes. Null is actually at the bottom of that type hierarchy, meaning that null doesn't reference just one type. It doesn't reference object. It references every type. So null represents every type, not just one type. And because of that, what the compiler will do is say, well, hang on, null could be anything. It represents everything. So I can't determine from that list is going to be any particular type. So even though object would be valid, The decision in terms of the way this is implemented is not to do that. So you get the case of, okay, can't infer the type, can't just assign a null to it. Another example, we need a type on both sides. So we can't do var list on its own, and then even on the next line, say list equals a new array list of type string. That won't work either. And again, the compiler will say, can't infer the type of local variable list, cannot use var on variable without initializer. So this is something you need to remember, is you must have an initializer whenever you use var. And that also applies in terms of having multiple things on the right-hand side. So you can't say var list, comma, list 2, comma, list 3. That won't work, because obviously you can't assign things in having multiple things assigned. So what you need to do is have one thing, var list equals new array list of type string. Literals with var. Now, there are some good uses of literals with var, where it's safe to do this, and then there are some where it's dangerous to do this. Let's look at some safe use of literals. If our code is like this originally, we have a Boolean ready, which we assign to be true. We have a char called ch assigned to be the letter x, a long called sum, which we assign 0, and we explicitly state L to make sure that the compiler knows that. And we say string label equals foo, a string. Good. What we can do is change all of those to use var, and we will have no problem with our code. Everything will work in exactly the way that we expect it to, because clearly the compiler will infer from the fact that we've got true, the character x, 0, L, and foo, as in quotes, all of those are unambiguous. Let's look at some literals which are dangerous. Let's say we have 3 numeric values. In this case, we're going to have byte called flags, which will assign 0. We're going to have a short called mask, which will use octal number, hexadecimal number 0x7FFF, and we'll have long base equals 10. Now, if you were to use these variables, and let's say you wanted to send some information across a network, or you were storing it into a file to be read by some other application, and let's say that you're depending on the size of those values when you read them somewhere else. So you know that you've got 1 byte followed by 2 bytes followed by 8 bytes. If we were to use var in that case and replace those 3 primitive types with var, then this is dangerous. And the reason for that is that the compiler will infer all of those to be int. What it doesn't do is say, okay, look at the value on the right-hand side. What's the smallest thing that I can fit those into? Because it doesn't do that. So, okay, var flag 0, yeah, it would fit into a byte. Mask will fit into a short. Base would actually fit into an int. So there's no way, unless you had the L explicitly with the value, to indicate that it's a long. So in that case, all 3 would infer to be an int, and then what you end up with is 3 variables that you're writing to your file or your network connection, which are going to be 4 bytes followed by 4 bytes followed by 4 bytes. If you then try to read out 1 byte followed by 2 bytes followed by 8 bytes, all those bytes will be there, but the values will be all completely different and wrong. So you need to be very careful when you're using literals that you get the right inferred type for that literal. Beware of multiple type inference. If we have a situation like this, where we use the diamond operator, so priority queue of type integer, item queue is a new priority queue, and we use the diamond operator so that the compiler will infer for us that that priority queue is type integer. All works very well. Problem is, if we go through and we refactor our code, and we just look at the left-hand side there and we say, okay, let's just replace priority queue of type integer with var, and we get that. That's problematic, because what's going to happen here is we're going to have double type inference. And the first type inference that's going to happen is that the compiler is going to look at the fact we're using the diamond operator, and it's going to say, okay, we need to infer the generic type from the left-hand side. Oh, we're using var. So at that point, the compiler is going to infer that the type of that is from the left-hand side, but the only thing in that case, that it can infer is going to be object. Then we're going to have type inference on the left-hand side, which will say, what's the type of item queue? And we end up with an item queue, sorry, a priority queue of type object. Personally, I think this was a bad decision in terms of the design of this feature, because I would at least like to see the compiler issue a warning at that point to say, you've used a diamond operator. Did you really want to do that? Because it's going to infer object. Realistically, it should, produce a compiler error saying can't infer the type on the left-hand side because we don't know the type of the generic parameter. So you need to state that explicitly. Because in terms of your code, you might run into some, difficult to find bugs because suddenly your priority queue, which was of type integer, is now of type object. And when you try to store something that's, into that, it's not going to work in the way you expect it to, especially when you read things out and you've got an object rather than an integer. You can't call the methods on that you would expect to be able to call, and you get incorrect, or you'll get an error because it's trying to call methods on the wrong type. Programming to an interface. It's very common in Java to use interfaces rather than the concrete types. And by that, what I mean is we say, okay, I want to create a list, but rather than saying it's an array list explicitly, what we do is we say list of type string, my list equals new array list. And because array list implements the list interface, using polymorphism, we can view our array list as anything which is any of the interfaces that are implemented by that, or any of the super types. So in this case, we can legitimately say this is a list of type string, and we can view it in that way, and we can pass it around in places where we need a list. If we use var, var is always going to infer the concrete type. If we say var my list equals new array list of type string, then what we'll end up with is my list being an array list of type string. But of course, array list of type string is still a list of type string. So the important thing to understand is that polymorphism still works in this situation. So array list of type string is still a list. And so if you want to pass that as a parameter to another method as a list, it will work quite happily. So some people get a bit hung up about this and they go, oh no, this is going to break things, because surely by treating my list as an array list of type string, whereas I want it to be a list of type string, that will break things. The only thing that you would be able to do that's different if you use the first line there and say it's a list of type string versus using var my list is that you would be able to call more explicit methods on my list, because you could call the methods of array list which you couldn't call on my list in the first example. But if you're refactoring your code, then that's never going to happen because you're treating it as a list anyway. So you're only calling the methods of list rather than the methods of array list. So in this case, programming to an interface, not a problem. You can still use my list wherever a list is required. So there's no problem with doing that. Lambdas and var. Okay, so we can assign a lambda to a variable because a lambda is simply a representation of a functional interface. Functional interface has a single abstract method, and our lambda expression is the implementation of that single abstract method. In this case, we've got predicate of string, call it blank line, and then our lambda expression says that what we want to do is take a string and return is that string blank. So that will implement the method in predicate, which I can't remember what it is, test, I think it is, which takes a string with generic type parameter and returns Boolean. So that will fit. That will work quite happily. We could then think, okay, maybe we should use var there. We'll use var blank line and use our lambda expression. But this is another example of where we've got a poly expression rather than a standalone expression, because depending on where you use that lambda expression, this is actually a bit more easy to see if you think about it. Depending on where we use that lambda expression would dictate what type is required for that functional interface. So yes, we could expect the compiler legitimately to infer it's a predicate of type string, but I could implement my own functional interface with a single abstract method, which takes a generic type parameter, which in this case will be a string, and returns a Boolean. And so that Lambda expression would still be quite legitimate in terms of implementing that method. So the compiler would then go, well, hang on, I could use predicate of type string, or I could use Simon's method of type string, and both would work. So it's not clear which one is going to be used there unless we could see where it was being used. But in the case of the assignment here, we don't know where it's being used, so we can't infer the type. And we get an error which says Lambda expression needs an explicit target type. In JDK 11, they extended how you could use var, and they extended it specifically to Lambda parameters. Okay, let's see what we mean by that. Well, here's an example of using a Lambda expression. So I've got my map, and I've got a Lambda expression which says I take the variable s, and then I map it to the lowercase version of s. In JDK 11, we can now do this. We can say var s and map to s.lowercase. Obviously, you'd look at that and you go, why would I do that? Doesn't make any sense, because in terms of the way that Lambda expressions and streams was implemented, they already had type inference, because the compiler can see that it knows the intermediate types. We've got our list, we're creating a stream of that. Therefore, that is a stream of strings. So we're then passing that into map to map that string into lowercase. So the compiler is inferring that s is of type string. So why would we possibly bother adding var to that to tell it to infer the type? It already does that. Well, there is only one case where that actually makes any sense, and that's if we want to use an annotation. So if we want to use an annotation such as this, we can say not null var s map to lowercase. And in that case, if you wanted to use an annotation, you must have a type in the Lambda expression. So you can't simply leave it on its own. You couldn't have at not null s. You have to have a type in there, which you can either state explicitly, or you can just make it easier by using var and let the compiler, although the compiler is going to figure it out for you, it just makes the syntax right for using an annotation on a Lambda expression parameter. Intersection types. Now, this is one of those things where local variable type inference comes in very handy, and it solves a problem which you can't get round in any other way in Java. So let's have a look at an example of this. In Java, we have generic types. So we can do generics, have done since Java SE 5, and we can do something like this. So we can say, I've got a method called getData, and getData is going to return an object of type t, so it's generic. How we want to define t is that it's a type which extends closable and iterable of e. Again, this is one of those places where I'd be a little unhappy with the way that the people who design generics used syntax which was incorrect. The reason I say that is because what we're doing here is we're actually not extending, we're implementing. Closable and iterable are interfaces. So the syntax already exists in Java because you have a class which implements multiple interfaces. You extend a class. So what they should have done, in my opinion, is they should have said T implements closable and iterable of type E. But for whatever reason, they decided to use extends. So now we have T extends closable and iterable of type E. So there is a situation where you can use the ampersand there, rather than being a bitwise operator. In this context, what we're saying is that we have multiple interfaces that are being implemented by the generic type that we're going to return from getData. So it will do some work and it will return an object whose type implements both closable and iterable of type E. So that's valid Java syntax. The problem we have is if we want to use that. So here I've got a method where I'm going to say, okay, this is first match and takes a predicate and returns an optional. But the important thing is that what I want to do is I want to retrieve from my getData method some elements. And then in terms of using that, I want to say, okay, I want to try with those elements. And because I'm using it in a try with resources block, I must have a type that implements closable. Okay, that's great. So I could make elements closable equals get data, and that would work because polymorphism, and then I could use it in my try with resources block. The problem comes in the fact that I'm going to use splitterator on elements. And in order to do that, I need to have something that implements the iterable of type E interface, which is fine because obviously the get data returns something that does that. And I could, in terms of my XXX there, I could say iterable of type E elements equals get data, and that would allow me to call the splitterator method on that. But then I wouldn't be able to use the elements in my try with resources block because it's no longer closable. What I need is some syntax which allows me to represent a type which implements both closable and iterable of type E. Now I can do that. It's actually a very simple solution. I can do one of two things. I could create myself a new class, which I'm going to call, let's say, foo, and it's a foo which implements both closable and iterable of type E. And then when I create my elements from get data, I simply say foo, and everything will work. Or I could do it with an interface, and I could say interface foo extends closable and iterable of type E, and that would all work as well. But that then introduces a certain element of type pollution. We're creating either an interface or a class where potentially we could only use this in one situation. And in that one situation, to create a whole new class or a whole new interface for that is not really ideal. So now with local variable type inference, we can solve this problem. Because if we use the syntax that we have for the generic type parameter, we can't say what we really want to do, which is closable and iterable of E, because that won't compile. The syntax doesn't work in that case. What we can do is we can use var. So we can say var elements equals get data. And then when we try with elements, that will work because the elements will implement the closable interface. So it's a type that implements closable, therefore we can use it. When we try and call splitterator on elements, that will work because whatever is generated by the compiler will have the right type and it will implement the iterator of type E, iterable of type E, and so we can call splitterator on that. What we've got here is the use of non-denotable types. And how this works is that in Java, obviously we have the syntax of the Java language. We compile it into bytecodes, and that's run by the JVM. Now the JVM can actually understand more types than you can represent in the Java language. This is a classic example, that we have no way of representing both closable and iterable of type E, but we could represent that to the JVM through the compiler. So what the compiler does is it says, oh, okay, elements needs to be something which implements both those interfaces. And so it just generates something for us that the JVM understands. But we don't have to worry about that. So by using what's called a non-denotable type, we can solve the problem and our code will compile. Here's another example of using var. And in this case, we're going to use it with inner classes. And this is one of those situations where I look at this and I go, okay, this is valid code. It's not something I'd recommend. Because what you can do is you can create a new inner class and you can say object fruit equals new object, and then specify that that object has string name equals apple and a method called string in French returns pom. Now that code on its own will compile. There's no problem with that, which is kind of weird to me because, object doesn't have a name field. It doesn't have an in French method, but that will compile. The problem comes when you try and reference those, either the field or the method from that fruit object that you've created, because at that point the compiler goes, oh, hang on, fruit object doesn't have a name. It doesn't have an in French method, so that will fail. Again, we can solve this problem by using var. So we can say var fruit equals new object, string name in French method. And again, the compiler will use a non-denotable type, something that can be represented to the JVM but not expressed in the Java language, create that type for us, and then when we call fruit.name or fruit.inFrench, it will work. As I said, this is like a good example of what not to do in Java code. I would never suggest writing something like this. It will work, but I don't recommend it. Okay, last thing to understand about var is it is a reserved type, not a reserved keyword. What does this mean? Okay, well, in JDK 9, you could have done something which you can't do in JDK 10. And specifically, you could have created a class called var with a lowercase v. In Java, you can create classes with lowercase variable names, or a name that starts with a lowercase letter. That's legitimate because the variable names only have to have letters in. They have to have letters in them, but you can certainly start one with a lowercase v. But obviously, you never would, because the convention is to use an uppercase character for the name or the first letter of the name of a class. So in JDK 10, you no longer can do that. However, you can still create, as you would have done before, a class called var with an uppercase v. The implication of the fact that this is a reserved type, not a reserved keyword, is it means that it doesn't prevent you from using var as a variable name, which is kind of good, because I'm pretty sure that plenty of people have used var as a variable name in the past. And if we had made that a reserved word, then it would have broken a lot of backwards compatibility. The reality is, though, that what you can do, and again, I wouldn't suggest this, is you can actually do var equals new var. So again, wouldn't recommend that, but you can do it. I tried it, syntax works, the compiler is quite happy with that. Okay, now what I've done is I've put sort of was for trying to see if you understood what I've been talking about. Now, I'm not quite sure how we're going to make this work, because normally when I do these presentations, I can do it in front of an audience and I can see people put their hands up and ask a question and so on. But we'll just probably have to do this where I will tell you the answer and we'll sort of go through it. So let's say I've got a method called calc1, takes an int called mask, then has a long temp, which has got a value, and then we return a fairly complicated thing where we say we're going to left shift temp by 6 bits, we're going to OR it with temp, then we're going to AND it with the mask and return whether that is greater than 0 or not. Now the question is, should we use var for temp? So should we say var temp and then return temp left shifted 6, order with temp, and it with mask? So actually, let's see. So I don't know if we can do this. Let me just see if we can get somebody to answer the question, why shouldn't you do that? Can I see? I'm not quite sure if I can see the, let me just see if I stop sharing my screen for a moment. Okay, so somebody put something, yeah, try putting something in the chat if you know why we shouldn't do that. Anybody? Ah, there we go. Yes, there we go. So there you go, Marek. So I know we were going to give away some licenses for JetBrains, weren't we? So I think Marek gets one of those. Yeah, you told that var is int always. That is correct. So where are we? Share my screen again. Okay. Yes. So the problem is, coming back to what I'd said earlier about the fact that literals you need to be very careful about. And so the situation here is that the number we've got will fit into an int. So if it fits into an int, then the compiler will infer it as an int, not as a long. If it goes beyond what will go into an int, then we will still get the, then it will become a long. But in this case, we'll get an int. And what that will cause is some different behavior. So if we pass a mask which is less than 0, we get different results. So if we use a long, the original code, and we pass a mask less than 0, we return true. If we use var and infers an int, we pass a mask less than 0, it's going to return false. So it's a slightly convoluted example, but it gives you the idea that we need to be careful about using literals with var, because it can change the way that your code behaves. Okay, second puzzle here. So what I've got here is a method called create1, takes 2 booleans, foo and bar, returns a list of strings. So what I'm going to do is I'm going to create an array list and I'm going to assign that to my list. And then I'm going to say if foo is true, add foo to the list. If bar is true, add bar to the list and return the list. So my question is to you, should we use var here? Would this be a good use of var? So here you go, if foo, add foo to list, add bar to the list. Now let's see if I can see the chat. Or do I have to stop sharing my screen? No, there we go, chat. Okay, so yeah, okay, so hang on, let me, so who got that first? Yeah, we go. So Radislaw, hopefully I pronounced that correctly. No, due to double inference. You are correct, well done. So the problem is, of course, that we've got the diamond operator there. And so we just replace that with, we haven't explicitly specified the type. So we're going to infer that it's an object as our generic type parameter, and therefore we will get an error. Incompatible types, array list of object cannot be converted to list of string, and we'll have a problem. So we will see that as a compiler error rather than a runtime error, but you can still see that that's not a good way of using var. Okay, puzzler 3. Okay, so I'm not actually going to use this one as a question, although I will see if anybody can guess this, because it's too convoluted for this particular bit. Anyway, so what I've got here is a method which is called list removal, and that's going to return a list of type integer. Okay, so in my method, I create a new list and I say it's an array list, and we'll put 13579 in there. And then we're going to call value to remove on that, and we're going to use var for that. So we're going to use var straight away. And then we do list.remove v and return the list. Then we've got another method, which is value to remove, which is defined somewhere else. And it's going to be not in necessarily in our code. It's in a different class, a different package, or a module in a galaxy far, far away. And in this case, what it does is it says value to remove returns an integer object, and it returns 3. So clearly we're using auto boxing to say create an integer object with 3 in it, return that, it all works. So that's fine. Why? Okay, let's see if why would, can anybody think why that wouldn't be a good way to use var? I am going to say this is not an obvious one. So I'm probably asking too much of the audience at this point. Okay, so nobody's actually stepping up to the plate on this one. So the answer is that by having that method somewhere else, what could happen is we have a new intern that arrives and looks at the code there and says value to remove. Aha, hang on, that's returning an integer, even though we're actually returning 3. Now, I've just done my degree course, and I need to prove how good my programming skills are. So rather than returning integer, which creates a new object, which is placing a load on the garbage collector and so on, I'll return an int rather than an integer. And that should still work in the same way, shouldn't it? Because we'll unbox it at the other end. Aha. Not always. So the problem that we get here is unexpected change in behavior. I did say it was a bit difficult to guess. And the answer to that is that there are 2 overloaded methods in list for remove. One, which takes an int as a parameter, and that will remove the element at the given index. And the second one is remove, which takes an object, which will remove the first instance of that object. If we use those 2 different pieces of code, the one where we're using var with the changed value to remove, so when we've changed it to an int, we'll get 1379 as our list, because we'll remove the 3rd element in the list. And if we use the unchanged code, so we're using an integer object, we'll actually get 1579, because it will will remove the first instance of 3 in the array. So this is, I did warn you, it was a bit of a convoluted one, but it does show the problems you can have in Java when you use things like var, when you use auto boxing and unboxing, and they combine together, and overloaded methods as well, can all add up to a situation where you could find tricky to resolve bugs. Okay, so last bit then, guidelines for use of var. Obviously, what we want to do is make our code more readable. So reading code is more important than writing it. That's the fundamental thing. This is a set of guidelines that were written by Stuart Marks, who was one of the people who did a lot of the work on local variable type inference. So he wrote an article about this. And he says, code should be clear from local reasoning, and you shouldn't rely on the IDE to say, okay, well, what type am I using there? I'll hover the mouse over that and it will show me what the type is. Choosing variable names is very important. I'm sure you realize that, so make them meaningful, make them clear so that you can reason from the variable name what is going on, what type it's likely to be. Minimizing the scope of local variables, because obviously the further or the bigger the scope you have, the more opportunity there is to miss where the variable is being assigned and therefore what the type is. Think very carefully about the use of generics, think very carefully about the use of literals because of the obvious examples that I've talked through there. So just to conclude, local variable type inference is a very useful feature. I think there's some very good cases where it makes a lot of sense to do that, but be careful. Great power comes great responsibility, and consider the implications of using var, especially when you're going through and thinking, okay, I'll just refactor my code and just replace things with var. Much better, I think, to use it more when you're writing new code. So that's the end of the presentation. I guess it's time now we can do some questions. And let me just go back to there. Yeah, so I know we had two more licenses that needed to be given away. So did you want me to just, I've got a couple of questions here that I can ask, so we try that. I guess that's a yes. Okay, so the question is, I'm looking for the answers. Why can't you use var with a lambda expression? So the idea is somebody will answer on the chat box, hopefully. Okay, somebody said not null. Nope. So my question is, why can't you use var with a lambda expression? Okay, yep. So there we go. So because different objects can have the same method. So I think you're right in what you said. So Jan Nowak. So yes, it's because of this idea of what's called a poly expression. So the fact that you can't tell from when you create a lambda expression what particular functional interface it would implement until you actually use that lambda expression. So it's the type that's the important thing there. Okay, I think one more question. Is that right? I'm guessing. Let me see. Quick look, because I had another question there. If anybody has got any questions, please feel free to type those into the chat box as well, because I will address those.
Yeah, actually, Simon, I have one question.
Sure.
But
okay.
I can't use Q&A section, but sure. Maybe I will ask you at the end. Okay.
Okay.
So, yeah. Do we have any other question? I see questions from Marek. Do you see it, Simon?
No,
in Q&A section, or it is already answered?
I need to. No, I don't see the question. Oh, hang on. As you told, var maybe was introduced Java because JavaScript, but in JavaScript is that var is a box of something. Yes, I mean I was being somewhat facetious by saying that because JavaScript has it, it's a good idea to add it to Java. Now, I think the idea is that var is different to the way that it works in JavaScript. So it's much more about, as I said, making the code more readable by eliminating some of this extra stuff that we have. And the obvious example is where we're duplicating the type on both sides of an assignment. So where we use var, it just makes the code a little bit tidier. And so the example of try with resources block was a good idea, because obviously that makes things, tidies the code up and stuff like that. So that's why var is different to the way things work in JavaScript. I probably should take that out of my presentation. Okay, so so here's another question for the audience, so see if people were taking note of what I was saying. So what is the name of the thing that we can use if we want to use either an intersection type or an inner class? So what is it that the compiler is able to do? There's a specific thing I said that it could do in order to solve the problems that we had. So I mentioned a type. What was it that the JVM can understand, but you can't represent in the Java language? Let's see if anybody gets this. Okay. Hoping that somebody will say that. Not seeing an answer at the moment. Okay, let me see if I can come up with another question. Right. How about this? And give me an example of where you wouldn't use var. Okay. Hoping somebody's going to answer a question, because then we've got one more license that we can give away for JetBrains. I'm not seeing any answers here. So you said you had a question for me?
Actually, we had only 2 licenses. Now we have books from mining.
Oh, okay. Yeah, you said you had a question that you were going to ask?
Yes. So in one of latest version of Java, we got new feature related with transforming switch from statement to expression.
Yes.
So you know already my question.
Can you use var with it?
Yeah, and question is it possible to assign switch expression to var? And what if we will return from one case, for example, int, and from other case string? And what will be really type of var? Because it should be established during compilation, right?
Yes. So that's an interesting. That's an interesting question, you see, because a switch expression obviously will depend on what's returned from the individual cases. Now, I haven't actually tested this because I don't know whether you can return an int from one case and a string from another. I don't think you can. I think you can only return an int from or a single type. But because if you use the switch expression without var, you have to explicitly state the type. So if you were to return, if it was possible to return both an int and a string, then the only thing that you could use as a valid type would be object, because you could auto box the int into an integer, and then you could use object as the return type. So that would potentially work. I guess var would infer that, but I've got to say, I've never tested that. It's an interesting question. I will have to now go and try that to see whether it is even possible. But I'm not sure whether the switch expression will allow you to return different types from the switch of the expression. So I'd have to test that first.
Okay, so I will need to test it.
Yes.
So I think that will be all. I will only share a feedback form.
Okay.
Actually, there is also one more question.
Sure. Yeah, so maybe tuple would be a good solution for this. In another case, var works in the same way as in JavaScript. Yeah, I suppose. I mean, because it'd be interesting to see whether you could use, rather than a tuple, you could use a record. Yeah. Yeah, I must admit, I'm not really a JavaScript programmer, so I'm not really too familiar with the way that it works in JavaScript. But yes, you're right. A tuple could be a good solution to that. Right. Oh, okay. Yeah, switch expression. Yes. Okay. I don't see any more questions.
Yeah, so if anyone don't have any question, we will approach to end. So Simon, thank you for being with us in that hard pandemic time. Yeah, and provide us a bunch of good knowledge. And also thank you all attendees for coming.
Yeah, thank you very much. It's been a pleasure.
And Pavel, do you have add something?
No. Also, I'd like to thank you, Simon, for being here today. And I think that's all.
Okay, great.
So thank you all. Thank you, Simon, again. And see you maybe in next year
Yes.
in normal time.
I was going to say, hopefully at some point I can come back to Poland.
Did you ever been in Poland?
Oh yes, I've been to I've been to Warsaw a few times, and I've also been to Krakow a couple of times as well.
So I think that's all.
Thank you very much. Okay, bye-bye.
Bye.